Hello and welcome to another video. In this video we're going to be doing reverse linked list, and you're given the head of a strongly linked list and you want to reverse it and return it. So in this example, basically what you want is you want to take all these pointers and make them go the other way. So 5 points to 4, 4 points to 3, 3 points to 2, 2 points to 1, and 1 points to nothing, kind of like this. Same thing here, you just want to take all of these and reverse. So this is a very core linked list problem, and this is one that's used for a lot of other problems. So definitely one that you need to know very well, and I'll kind of show you one way you can do it. So basically, here's our linked list. So what we want is like every node's pointer to point back, but we also want to traverse forward. So if we make this, like if we just take this and make it point back, we need to be here before we do that. So basically the idea is we can just go to the next node and then store the previous node and make it point back. And then keep traversing. So we're gonna have 2 pointers here. So one pointer will start at the head and the other pointer will start at null. And our algorithm will basically be, I guess technically we might need like 3 pointers. So the third pointer will be the temporary variable that we use to store the next node. So what's going to happen here is, let's actually use 3 different colors just to make it a little bit clearer. So we will have our previous pointer, and then we'll have our current node, and then we'll have like our, and then we'll have our temporary node that's going to be the next one. So like this. So we're going to say, like, we're going to start here. We're going to say, okay, we want to get this node. We want to save it. So we're going to say, like, let's get current next, save that in a temp variable. Then we want to make current point to previous. So this arrow will go the other way. I don't know if I can turn it. Okay, looks like I can. So this arrow will point to null. So basically it'll not exist. Then what we want to do is we want to make current become previous. And we want to, or make current become temp, and we want to make, before we do that though, we need to make previous equal to current. So this is our previous, so we can make previous equal to current, and current become this temporary node that we made. Then once again, the temporary node will be the next of our current node, so it'll be over here. Then we take the next pointer of the current node and we set it equal to previous. So this will now turn around. Then we make the previous node equal to the current node, and we make the current node equal to the temp. Then we do it again, so the temp will be the next of the current node. The next of the current node becomes the previous node. So swap that around. Then the previous node becomes the current node, and the current node becomes the temp. And then we do it again, so the temp becomes the next of our current node. The current node's next wants to point to previous to make it go backwards. Previous equals current, and current equals temp. And then we do it one more time. So temp will be the next of this, which is nothing. Then the next pointer of our current node will point to previous. So this will just be like this. Then previous will equal our current node, and then our current node will be temp. So we just keep doing this until our current node's out of bounds. So now this is all out of bounds, and now our previous is going to be the head of the new linked list. So we do this, and then we just return the head of the new linked list. So kind of a core problem, and you basically use two nodes, your current and previous, and you use temp to temporarily get the location of the next node so that when you cut the link, you can traverse to it still. I mean, that's going to be pretty much it. So let's code it. And I think I'm going to start doing some problems in Java. I haven't done Java in a while, so good practice. And pretty much everyone does Python. So let's try to do this. So what we need is a previous node that's going to be null. So we can just say like list node. Hopefully don't screw anything up. Previous. I think if I do it like this, it'll be null. Then I want to say list node current equals the head. And then we basically want to have a loop while current is not null. So while current does not equal null, I believe. I can just do that. So what we want to do is we want to make a temp node. So list node temp equals cur.next. Then we want to make our current point to the previous. So cur.next equals previous. Then we want to make our previous equal to current node. So previous equals cur. And finally cur equals temp. So we keep doing this, and finally at the very end, just like in the picture, current will be out of bounds, and previous should point to the new head of the list. So we just want to return previous. Let's take a look. I don't know why I have this timer. Let's see what errors we have. Let's actually reset this timer. Let's take a look. Previous might not have been initialized. Okay, so I guess I have to make it like null or something. Let's see. Okay, there we go. I thought if I didn't initialize it would just get auto initialized. No, I guess not. Okay, so there we go. So it works, and yeah. And Python very similar as well, but I think I'll start doing some problems in Java. The nice thing about doing problems in Java, by the way, is it's actually like putting more, like it's harder than Python because it's static and your variables actually don't have infinite length, so you can't just make an integer of like a billion digits. You have to actually do a little bit more thinking. So I think it's good practice for like tougher problems. But yeah, let me know what you guys think about doing problems in Java, and let me do the time and space here. So time is pretty straightforward. So let's use a Java comment. It'll be O of n, and space will be O of 1 because we're just using a couple pointers. So yeah, gonna be all for this one. Hopefully you liked it. If you did, let me know. If you didn't, let me know. If you don't like Java, let me know. Whatever. And I'll see you next one. Thanks for watching.